Welcome to our UPM MOOC Technical Drawing for Mechanical Engineering. We are in Module 4. We are studying part features. Let's start with Module 4, Unit 3. Unit 3, Repetitive and Angular Features. The first feature we are going to study is the chamfer. Like fillet, chamfer is used for eliminate sharp edges and corners, but is more economic to manufacture. The chamfer has an angle and a depth. A view showing the angle is required. If the angle is 45 degrees, only one dimension is necessary. The dovetail. These features are made for pairing male and female. These pairs function as sliding guides when we allow the movement along the symmetry plane, but not in the other directions. To fit adequately the pair, these dimensions have to be the same in male and female. These dimensions are the angle between floor and side of the dovetail. This is due to the tool used for manufacturing the dovetail. Then the width of the narrow bases and the height. A view showing the angle is necessary. When we have an angle in a part, we need compulsory a view showing this angle. Repetitive elements. There is no doubt that repetitive elements are present in a huge quantity of parts rounding our life. To represent them, firstly, a single element is described. Then, the repetition pattern is also described. In some cases, a simplified representation can be used. The first case is element equally distributed in a circumference. This is the most common case of repetition. We can find this pattern in a huge quantity of parts. First, the single element is described in this example, a single hole. Then, the diameter of the circumference. Well, the angular separation between single elements has no dimension. If one single element coincides with a principal plane, no more dimensions are necessary. Well, a question is the number of holes. Normally, the number of holes or elements, repetitive elements, is very easy to see in the views. If there is a more complicated case, we can to explicit describe this number of repetitions. Elements equally distributed in arc. In this case, we don't have a complete circumference. Instead of this, we have a partial arc. Of course, the single axis is described. Then we have to describe the arc, first with the radius. The angular separation between the singles is placed in an overall angular dimension indicating the number of separations and the overall angle in brackets with the equal symbol. In this case, we have 6 holes. So we have 5 distance between holes. The corrected dimension consists on 5 times the single separation, in this case 26 degrees, and the overall angle is equal to 130 degrees. In some cases, we require dimensions for the location of the arc center and to establish the beginning of the arc. linearly equally distributed. In this case, the single element is discrete, and as in the prior case, the linear separation between singles is placed in an overall linear dimension indicating the number of separation and the overall separation in brackets with equal symbol. Some cases can require dimension for the position of the segment pattern. Well, we find also cases of many repetitions. If there are many repetitions of elements, it's not necessary to represent all of them. In this case, we will describe the single element and the pattern side, but in this case, we are not going to represent all the contour of the elements. In case, the axles, or in this case, nothing. But always we have to describe the number of repetition of the element. Only required to represent the minimum to clarify the layout of the pattern. In this case, we have a pattern, a rectangular pattern that have 3 rows and 10 columns. For clarifying, because we are not drawing all the squares, we have 9 times 16. We repeat the distance between 2 single holes to clarify that the distance is 16 and 9 the number of the separations. Well, now let's summarize module for Unit 3. What have we learned? Chamfer is an angular feature used to eliminate sharp edges. Dovetail is another angular feature for making sliding guides, pairing male and female profiles. The representation of elements repetition consists in 2 steps. First, we describe the single element, and then we describe the repetition pattern. Repetition pattern can be circular, whole circumference or partial arc, and linear, segment, or rectangular. If there are too many repetitions in a pattern, we can use a simplified representation, always keeping a clear representation of the pattern. We have finished the module 4. We hope to see you in the next module, module 5.